This one is pop quiz, past paper pop quiz 3. A page of a printed text is placed 18 centimeter from a converging lens of a focal length 35 centimeter. Figure 6.1 is a scale diagram of the arrangement of each of the two principal focuses, the focal points of the lens. This is shown here. A length of a 1 centimeter on the scale represent actual 5. So 1 centimeter is equals to, like 1 centimeter on the scale actually represent, actual length is 5 centimeter. By drawing on a figure, locate the image produced by the lens and label that as I. Remember, whenever object is between the focus and the lens, the image will be a virtual image. So, how we'll draw this virtual image? This is the first question of the quiz. So first, a parallel light ray. First, a parallel light ray. From where it should pass through? It should pass through focus. So we'll pass through the focus. Then one through the center, what will happen? It will pass straight. Will they meet? No. They will not meet. So what we will do? We will produce it backward. So when we produce it backward, what kind of image is this? Real or a virtual? Virtual image. So when you produce it backward, the new position of an object which we call an image, so this will be a virtual image. So first, a parallel light ray passes through the focus, one through the center will pass straight. These two light rays will never meet. One through passes through focus and one through the center never meet. So what will happen? We produce using a scale, we produce it backward. So the position where these two light rays will meet, that will be the image. But if you see, this question is a bit different. Like usually when they give us the object was either above the principal axis and below the principal axis. But for this object, part of it is above the principal axis and the part is below the principal axis. So what we have to do? We have to do for the second part the same thing. So what we have to do? Again, a parallel light ray. From where it will pass through? It will pass through focus. One through the center will pass straight. Again, these two light rays will not meet. So what will happen? We produce it backward. Yeah, it will be there, the same place. So when we produce it backward, this will be the new remaining part of the image. Because why we did twice? Because part of the object was above the principal axis and the part of object was below the principal axis. So that is how the image will appear. That is how the image will appear. Okay. Yeah, look, there are two types of question related to lens. One is the object is only above the principal axis. If an object is only above the principal axis, you will use only one part of it. But in this one, the part of an object is above the principal axis and the part is below the principal axis. So you have to use both parts. Okay. So in exam, you have to see what kind of object is given. Either it is only above the axis or below axis or halfway above, and like some part is above, some part is below. So that's how you have to draw an image. Using figure 6.1, determine the actual distance of image. So how you determine the actual distance? So what you will simply do, you will measure. They already mentioned the scale. This has to be done according to the scale. We know 1 centimeter is equivalent to 5. So 1 centimeter is equivalent to 5. So what we'll do, we'll measure this distance using a scale, a ruler. Using a scale, you will measure this distance. Let's say it is, you can use that also, like 18 centimeter, and this ratio you have to use the idea. So let's say this distance was 5 centimeter. So if this was 5 centimeter, it won't be 5, but let's say it was 5. So this will be x, cross multiply. According to the image, it will be, because you cannot have in this one exact number. It depends on the position. Okay. So you just have to measure the distance of the image from the lens and use a ratio of the scale. A converging lens can be used as a magnifying glass. State whether the image produced by the lens as a magnifying glass is real or a virtual. So it is virtual. And why it is virtual? Virtual images, yeah, cannot be seen on screen, or the light rays does not intersect by themselves. Like does not meet or intersect by themselves. That's why. Suggests how someone whose long-sightedness may be benefit from converging lens. So what actually happen in a long, we have the defect of the eye, long and the short-sightedness. In a long-sightedness, what will happen? The lens is not able to convert the light rays at the retina. So lens is not able to converge the light rays on the retina in a long-sightedness. Long-sightedness means we can see objects which are far, but not the objects which are close. So how the convex lens help us to work? Because the convex lens will have a shorter focal length than our eye lens. So as a result, what will happen? It will converge these light rays on the retina. So how someone with a long-sightedness may be benefited from using a converging lens. So one point we'll mention that in a long-sightedness, light rays converge after retina. So the convex lens with shorter wavelength, shorter focal length, so how to score the 2 marks? First mark is explaining what is a long-sightedness, what happened in a long-sightedness. So in a long-sightedness, the light rays converge after a retina. The point after that, it does not converge on the retina. So what will happen when we use a convex lens, which is having a shorter focal length, it will convert them on the retina. That's how it works. What? Converging or a convex? It's the same thing.
What's the other thing?
A diverging lens.